is chapter 11, and lesson 1 is expressing roots. Expressing roots. So this chapter, you get to get radical. Any radicals in here? Let's see. Are you radical? Look at Adriana. She is so radical. All right. So we'll get to the radicals. Got to start out with roots. And so some of these things we would have looked at before. Some of them would be concepts that are more new to you. So let's see. I didn't draw my box big enough, did I? All right. Let's do it this way. And take a second and shrink this up into the box. Okay, so expressing roots. And man, I'm a mess today. No shade or anything. Let's get that shade going. Let's shade off some of this stuff. All right, let's roll here. Okay, so do you remember the parts of a radical? First off, a lot of people want to call that the square root symbol, but we know that's not what it is, right? It is the radical sign. Come on, that was your chance to be radical. It's the radical sign. You know, last year in pre-algebra, radical sign, R-A-D-I-C-A-L. Yeah, I'm writing it up there. And it also goes in here as well. Right, the radical sign. So, you know, in pre-algebra, we dealt mostly with square roots. We did a few cube roots. But honestly, here, you know, it could be any kind of root. It could be a 5th root, an 8th root, a 20th root, etc. Could be a root beer, or it could be, you know, any kind of root. Root of bitterness, ooh, that would be bad. All right, we don't like those roots. No, we're going to do all kinds of different roots. So remember, it's not a square root symbol, it's a radical sign. It's a radical sign. And it indicates the operation. Right? Like adding is an operation, multiplying is an operation, absolute value is an operation. The radical sign tells you the operation of taking the roots. All right, so do you remember what we call everything underneath the radical sign? It's called the radicand with a D on the end. R-A-D-I-C-A-N-D, the radicand. Okay, so you got radical sign and you got radicand. It's anything underneath the radical sign, and it's what you take the root of. It's not good English, but it's great math. All right? It's what you take the root of. You're taking the root of the radicand. The root of the radicand. That could be like a song. Catchy phrase. Root of the radicand. All right. I see a root of bitterness welling up in some. All right. So you got the radicand up. I need to keep that there. And then, of course, the last thing is if there's something in the little crevice, it's called the index. So the index, and the index is key. It tells you what kind of root it is. And hopefully we all remember, if no index is shown, then technically the index is 2, and we all know that that's a square root. Right? That's old hat. So again, because square roots are common, most people then just think of it as everything's a square root, but no, that's only the root when no index is shown. Technically the index is 2, and of course it is a square root. All right, so some types of roots. Types of roots. All right, so everything is determined by the index. Right? It's all about the index. It's all about the index. It's all about the index. So you got to look at the index. All right, so index of 2 is a square root. I don't know why I was redundant there, but I was. But again, index of 2 is a square root. And I'm not going to spend a lot of time here because this was pre-algebra, but if I need to, I will. So ask questions. But when you see a square root, your brain should say to itself, self. What number times itself? 2 times equals the radicand, right? A square root, index of 2, what number times itself? 2 times, right? That's what a square root is. So when you look at the square root of 9, look, we all know the answer is 3. But why is the answer 3? Because the question is, what number times itself 2 times equals 9? What number times itself 2 times equals 9? And normally we just say the principal root answer. You remember that? Principal root? Principal root is just the positive part. We'll talk more about that a little bit later in the lesson. But normally we just technically say the principal root part. And the answer is 3. Why? Because guess what? 3 times itself 2 times equals the radicand of 9. Ha, yeah. What number times itself 2 times equals the radicand? And by the way, what is a 3 times a 3? It's a 3 squared. We're going to learn later on that whenever the exponent matches the index, the answer is the base, right? What's the square root of 3 squared? 3. What's the square root of 7 squared? What's the square root of 7 squared? 7. What's the square root of 132 squared? 132. What's the square root of 7.4 squared? 7.4. So what's the square root of x squared? X. What's the square root of z squared? Z. All right, here's one. What's the square root of parentheses x plus 1 parentheses squared? What's the square root of that? X plus 1, right? Got it? Follow? All right? And we'll talk a lot more about that when we deal more with simplifying. Okay, so again, square root of 49. I'm going to fly through this because, again, what number times itself 2 times equals the radicand of 49, right? And again, we know the answer is 7. And I'm not even going to finish it because, again, this is a review. But look, please, you need to ask questions because guess what? This is so simple to me, obviously. Not only do I know it, but I've been teaching it for 30 years, and you teach this in pre-algebra and algebra 1, so, how many times have I taught this? So it's crystal clear to me, but to you, maybe not, so you better ask questions. If you need to, ask questions, ask questions, ask questions, ask questions. Okay, so number 3, that negative is clearly, thank you, Windows, is clearly outside of the radical, correct? And that would be the same as a negative 1 times the square root of 25. So here I'm going to do it below. You still have the negative, and then what's the square root of 25? Well, that's a 5. And in this case, the answer is negative 5 because of the negative out in front. Again, we're only dealing with principal roots, and that's fine. And based upon what I said earlier, the square root of 17 squared is 17. The square root of anything squared is its base. Square root of anything squared is its base. All right, I need to go higher, so let me get rid of my shade. All right, so we know if the index is 3, then obviously it is a cube roots. Cube roots. And now you've got to shift your thinking into what number times itself 3 times equals the radicand, right? So now when we have a problem like the cube root of 8, we say, what number times itself 3 times equals an 8? And the answer is 2. Why? Because 2 times 2 times 2, 2 times itself 3 times equals the 8, right? What thing times itself 3 times is an 8? A 2 is the thing that when you do it times itself 3 times, you get an 8. Again, we got to think that through in our minds and keep that straight. And look, you can do the same thing here, right? Notice a 2 times 2 times 2 is a 2 cubed. And whenever the exponent matches the index, the root is the base. Now, before I go to the second example there, when we did square roots, I said technically the answer is really plus or minus. So let me just look at this for a second. Don't write this. If you had the square root of, let's use 9. Okay, the answer is 3. That's called the principal root, the positive part of it. But you know what? It could also be negative 3. Because isn't negative 3 times negative 3 also equaling the radicand of 9? Yes? Do you agree? Do you concur? All right. So technically, any even root, the answer is plus minus. But normally, we just worry about the principal roots at certain times. Is that the same thing for an odd index? A 1, a 3, a 5, a 7, a 9, an 11, an odd index. Is the answer 2, or can it also be negative 2 for a cube root? Is the cube root of 8 also negative 2? Well, to answer that question, does negative 2 times negative 2 times negative 2, does that equal positive 8? Because isn't the radicand positive 8? So negative 2 doesn't work, does it? And that is the case. Anytime it's an odd index, or I keep saying 1's boring, 3, 5, 7, 9, 11, then it's only the positive part is the only possibility. All right. Hopefully I didn't get too far afield there and get you confused. We'll deal more with principal roots and such coming up. But again, when it's a cube root, there's only going to be one answer anyhow, regardless of principal root. So again, this problem, what number times itself 3 times equals the radicand, which in this case is an x cubed. And therefore the answer has to be, x, not x cubed. You can't just like disintegrate the radical sign. Because if you want to say the answer is x cubed, all you did was just get rid of the radical sign. It did absolutely nothing. But again, we're asking what number times itself 3 times is an x cubed. And the answer is x. Again, whenever the exponent of the radicand equals the index, the root is the base. Whenever the exponent of the radicand equals the index, the root is the base. All right, so let's go on. Next page. Okay, so again, if you got a negative out front, here, let's make it a little bit more interesting. We'll stick a negative 2. Make that a negative 2 out in front. Okay, again, all that is a multiplier of the cube root of 27. Would you agree? Now, what if you don't know what the cube root of 27 is? Then, in these simple ones, if I factor this, I get 3 times 9, and 9 is 3 times 3. So what number times itself 3 times is 3 times 3 times 3? And the answer is 3. Right? The cube root of 27 is 3. And therefore, we end up with a negative 2 times 3. And the answer to this problem would be negative 6. All right, so go ahead and do number 4. What do you end up with number 4? So you got a cube root involved, and you also have a 5 minus the cube root of 1,000. I'm picking easy ones so that you can handle it. But the cube root of 1,000 is 10. 10 times 10 times 10 is 1,000. And again, if you would just start factoring that, you would figure that out. And so the answer to that thing is negative 5, right? Just a little bit of compound problems. Look, there are certain things that you should know the answer to. So let me pause and let's go through some of that. Square root of 4 is, all right, square root of 1 is 1. Square root of 4 is, square root of 9 is square root of 16 is, square root of 25 is, right? And you can do this all the way. We should be able to go all the way at least through 13, because 13 squared is 169, so the square root of 169 is 13. What's 14? 228, I think. I think it's 228. So square, no, it can't be, because 15 is 225. What is it? 196. So square root of 196 is 14. Square root of 225 is 15. And beyond that, you know, those are the normal ones we know. All right, cube roots. Cube root of 1 is 1. Fourth root of 1 is 1. Fifth root of 1 is 1. Eighth root of 1 is 1. The 20th root of 1 is 1, because guess what? 1 times itself 20 times equals 1, right? Any root of 1 is 1. Anyhow, we should know the cube root of 8 is 2. The cube root of, what, 27 is the 3. Now it gets a little tricky. The cube root of, what's 4 times 4 times 4? It's a 64. So the cube root of 64 is 4. We don't know our cube roots as well. What's a 5 times 5 times 5? 125. So the cube root of 125 is 5, and beyond there it gets tricky. And that's about it of the common ones for cube roots that we would know just in our head. Anything else, we're going to have to factor and figure it out. And we'll get there and I'll show you that. Okay, so let's deal with, lo and behold, a fourth root. You can have a fourth root? Yeah. And a fifth root, and an eighth root, and a 79th root, etc. You can have all kinds of roots. Any of your grandparents still have a root cellar? They like put all their canning stuff in their root cellar. We were at an auction a couple weeks ago, a house auction, you know, the estate auction, and it had a root cellar in it. It's like an old house. All right. Usually like all kinds of spiders and everything in there. Lions and tigers and bears. And snakes, of course. Awesome. All right, so fourth root. Actually, if you begin to get the concept of how if the exponent matches the index, then the root is the base. So right now I'm just doing the p to the fourth, because does that 4 go to anything else but that p? No, right? We learned what's the base to an exponent. So the fourth root of p to the fourth is p. That part we just took the root of. Well, I don't know the fourth root of 16, but you know what I'm going to do to the 16? And I'm going to do this in black. I'm just going to start factoring it. A 16 is a 2 times 8, right? And an 8 is a 2 times 4. And a 4 is a 2 times 2. Now look, I can look at this two different ways. What number do I need times itself? How many times? I need it times itself 4 times. Don't I have 2 times itself 4 times? So what's the root of 2 times 2 times 2 times 2? It is 2. So I get a 2 for the 2, and I'll write it over here, and I get a p for the p. And the fourth root of 16p to the fourth is 2p. Now, if your brain doesn't like saying, okay, there are 4 2's, and therefore the root is one of them, you could also write 2 to the fourth, right? Isn't that 2 times 2 times 2? And you're right back to, oh, now this exponent matches the index, and the fourth root is the base. And you get 2p, sweet pea, whatever. All right, let's find each root. So when you're looking to find roots, you really need to factor the radicand. It's all about factoring, because you're trying to find as many factors as match the index. That's the key. This is the key to everything with simplifying radicals. When you have as many factors as match the index, the root is that factor. So let me just one more time try to get this to you, because this is the key concept. if you have as many factors as match the index, how many 2's do I have? 4 of them. I have as many as that as match the index. Therefore, what is the root? It, right? The 2, the factor you have as many of. I have as many p's as match the index. Therefore, the fourth root of them, the root of them is the p. That's what you're after. You're after finding as many as match the index. Okay, so let's go through some of these. All right, boring. Square root of 36. We all know is a 6, but why? Because a 36 is a 6 times 6. What's my index, though it's not shown? It's a 2. So how many factors do I need to be able to take the root? I need 2 of the same factor, and the root is that factor. What number times itself twice is a 6 times 6? A 6. The second example is a cube root. And again, we know these by heart, but what is a 125? A 5 times 25. And what's a 25? A 5 squared. And now what do we have? We have what number times itself 3 times? And we have 3 5s, right? So what's the cube root of a 5 times 5 times 5? It is that number of 5. It's a cube root. We're looking for 3 factors. We have 3 5s. Therefore, the root is that 5. We can take the cube root of those 3 5s. In the fourth root, we're looking for 4 of something. I don't know. Let's go 9 times 9. Okay, I only have 2 9s. Can I take the fourth root of 2 9s? Not really. I need 4 of something. But that 9 is a 3 times 3. And that 9 is a 3 times 3. And now look, oh, I have 4 3s. That's what I need. I need 4 of something to take the fourth root of it. And 4, the fourth root of a 3 times 3 times 3 times 3 is a 3, right? So the same thing as writing 3 to the 4th power. Different way of looking at it, same concept. When the exponent matches the index. But again, what I'm thinking of, if I got a fourth root, I'm looking for 4 factors of the same thing. If I have 4 of the same thing, I can take the fourth root of it. And I don't care if they're x's, y's, z's, quantities, numbers, it doesn't matter. If I'm taking a fourth root, I need 4 of them. Take the root of it. If I'm doing a cube root, I need 3 of them. Take the root of it. If I'm doing a square root, I need 2 of them to take the square root of it. That's the idea. If it were a fifth root, I'd need 5 of them, etc., etc., etc. All right, now it's time to get you confused. Any questions so far before I confuse you? Nothing yet? All right. I'm a little outside my box here, but who cares? All right, let's go ahead and do this. All right, even roots. This is what I mentioned earlier. An index of 2, 4, 6, 8. Who do we appreciate? So sad. All right. Guys, bum me out. That was your chance. Brownie points. All right, so any even index of 24, index of 78, index of 132. Though we wouldn't deal with indexes that big, but any even index of negative radicands result in a solution that is not a real number. Oh no. All right, I thought I was getting principal root. That's coming later. Let's still deal with negative radicands. So we say either not real, get real. Eduardo, get real. All right. Sorry, man. All right. So we say it's either not real because it's not a real number. It's not part of our real number set. And by the way, what are we talking about with real numbers? We're talking about natural numbers, whole numbers, integers, rational numbers, commonly called fractions, irrational numbers, things like the square root of 3, something you can't make a fraction, things like pi, right? Those are all together are our real numbers. There is no real number answer. So here's the point. Here we got the square root of 16. Let me get rid of the shade so I can go higher here. Here we've got the square root of 16. Notice we have an even index, right? A 2, though it's not shown. And we have a negative radicand. Can you find something times itself 2 times to equal negative 16? Does it exist in the real numbers? The answer is no, because a positive 4 times a positive 4 is a positive 16, not a negative 16. So positive 4 doesn't work. And a negative 4 times a negative 4 is a positive 16, and that's not a negative 16 either. And some students say, well, multiply a positive 4 times a negative 4. Well, you can't do that, because that's not the number times itself. Right? I mean, you got Raquel, and then you have anti-Raquel. Antimatter. You know what would happen if Raquel ever met her anti-matter person? Annihilation. They would be gone. They would wipe each other out. Right? Hey, the positive and negative are not the same. All right? You can't say positive 4 times negative 4. It's not the same thing. And therefore, we have no real numbers that work. And so again, this thing you would say, not real. That thing is not real. You have an even index and a negative radicand. You could say undefined, which, by the way, the answer to this, and you don't get this until Algebra 2, is really an imaginary number. And the answer is really 4i. It's an imaginary number. It's definitely not real, though. All right, we'll talk about imaginary numbers in Algebra 2. The second situation is also not real. Do you agree? That's not real. Again, 12 is an even index. Negative x, we have a negative radicand. That's not real. How about C? C is not a problem. What's the answer to C? Negative 2. Because guess what? Negative 2 times negative 2 is a positive 4 times a negative 2 is a negative 8. Again, if you can't see it, what happens if you multiply negative 2 times itself 3 times? You do get the radicand of negative 8. So how about this conclusion? Yes or no, can you have an odd index and a negative radicand? And the answer is yes. So it's not a problem having an odd index, a cubed root, a fifth root, a seventh root, and have a negative radicand. That can work because whenever you multiply a negative times a negative an odd amount of times, the result is always, uh-oh, you're not thinking. I hope you're catching this. That tells me you're not catching it. If you multiply a negative quantity times itself an odd amount of times, what will the answer be? Odd or will it be positive or negative? Negative. An odd amount of times, positive or negative? Negative. An odd times itself, an odd amount of times, right? Negative times itself, an odd amount of times would be negative, right? So therefore, you can have negative radicand, negative 8, and an odd index. Can you have a negative radicand and an even index? No, not real. You need to recognize that. You need to recognize that. All right. 5, I'm not a big fan of. It used to be the day when, you know, you couldn't find a calculator. Nowadays, everybody's got a calculator everywhere. But you should just at least know how to guesstimate the idea. So 5, to estimate the root to the nearest integer, what you do is find the root of the perfect square or perfect cube less than the number of the radicand and the one greater than the number of the, and that's radicand there in the blank. So if they were to ask you, hey, what 2 integers is the square root of 125 between? So I'm thinking, what's a perfect square less than 125? And see, I'm thinking 100, right? Oh, wait a minute. How about 121? Isn't 11 times 11 121? Right? This is an 11. And what's the next one? If 11 times 11 is 121, what's the next one? Square root of, which is square root of 144. Is the perfect square bigger, which is a 12? What two integers is the square root of 125 between 11 and a 12? This is really a question if you don't have a calculator, because guess what? Grab your calculator, punch in the square root of punch in 125 and hit the square root button. And it's going to tell you, everybody, punch in 125, hit the square root button. Why at any calculator? Anybody else not have a calculator today? What in the world? Josh, Ethan, and Wyatt, have your calculator with you every day, please, as always. Okay, so doesn't it tell you what? 11 point what? 11.18, so roughly 11.2. So look, you could just punch in your calculator and say, oh, it's between 11 and 12, right? Kind of boring. But that's the concept. And again, the concept here, again, we don't know cube roots as well, right? We definitely don't. So a 5 times 5 times 5 is a 125. That's a 5. And a 6 times 6 is 36 times 6 is 216. And that's the 6. So this thing would be between a 5 and a 6. But again, I'm not big on these because these days we have calculators everywhere. Every phone has a calculator these days. So, but find your cube root button. It's there on your calculator. Punch in the cube root of 211, and you're going to get closer to 6, I think, probably 5.8 maybe. 5.9 is going to be the cube root of 211. We normally deal with exact values, so I'm not interested in a decimal round off, although that is technically the answer, right? 5.9, whatever. But again, we're rounding off if we go that route. And so we do know it's between the integers 5 and 6, right? Not a big deal. I can do this next page. All right, I'm not going to deal with my shade. Changing between radical form and exponent form. This is an important rule, and this is something you should memorize, and it's not hard. Taking a root is the same as taking the radicand and having a fraction for the exponent. A fraction for the exponent. The numerator of the fraction is the exponent of the radicand. And the denominator of the fraction is the index. Now that's something you should memorize. So the b root of x to the a is the exact same thing as x to the a over b. Same thing as x to the a over b. Right, I'm running out of a little room here, but I also want to show you there's one other thing it's likened to. If I have the b root of x to the a, it's the exact same thing as putting the b root of x in parentheses all to the a power outside that parentheses. I'm trying to get that inside my red line there, and that's why, you know, if you were writing it, you'd put it a little bit more to the right there, right outside the parentheses. Just things that are the same. All right, so let me go a little quick through some of this, but you're going to have to ask questions. I don't want to go too fast to where I lose you. But look how easy this is. Look at number 1. That's it. I need a shade. Focus you guys' attention. Okay, so look at number 1. So number 1, you start with the base, the 2, right? What is the fraction going to be for the exponent? What's the top of the fraction going to be? 5. And what's the bottom of the fraction going to be? 4. 2 to the 5/4 power is the exact same thing as the 4th root of 2 to the 5th. Same thing. Equal. So, oh, Mr. Scarfy, are you telling me that roots and radicals are the same as a fractional exponent? Yup. Yup. I am. So look at number 2. So the base is 7. What's the value of the numerator? What's the value of the numerator? 1. There's a 1, but it's not shown. What's the value of the denominator? 2. It's not shown. Hey, that's 7 to the 1/2. The square root of 7 is 7 to the 1/2. Oh, let's see if you comprehend. All right, listen, mental problem. Ready for a mental problem? What is the value of 49 to the 1/2? What's the value of 49 to the 1/2? Say it if you know it. I heard the answer. All right? Maybe you haven't caught on yet. Give me 36 to the 1/2. That's correct. It is 6. Give me 81 to the 1/2 power. It is 9. Give me 144 to the 1/2 power. So what are we saying? A 1/2 power is the same as the square root. It is. It's the exact same thing. 1/2 power, same as square root. So look at number 3 here. This is going to be 5 to the what power? 1/3, right? The 1 not shown, right? We don't show 1 exponents. It's exponent over the index. All right, look at number 4. Whenever this number is completely factorable, you want to do that. So a 9 is a 3 times 3. So a 9 is a 3 squared. So what would this be in the other form? 3 to the, come on folks. I'm at a 3 squared. I'm taking the cube root of 3 squared. That gives me 3 to the what? Okay, if you are lost, you need to ask questions. There hasn't been one hand that's gone up yet. And if you're lost, you need to raise your hand. If you're not thinking, you're going to have trouble tonight. And this is your, look, I'm going to take a second amount of time, but I'm going to take it. If you're not thinking through these questions as I'm firing them out to you, and you're just sitting there in neutral, I really want to go back to, you're an idiot. All right, but I won't go there. You have got to be thinking. You've got to be engaged. You just can't wait for me to give you the answer and then write it. You didn't learn a thing. You've got to be thinking through these things. So what is the cube root of 3 squared? It is 3 to the... What is its exponent? 2. What is the index? 3. All right, now again, this is all we're doing. This is all we're doing. Its exponent is the numerator, the index is the denominator. All right, now look at number 5. This is a progression. I'm going to write the 1 in for the 2, though it's normally not there. I'm going to write it in red. Now we have a multiple situation. The 2 is the what power? What's the fractional exponent of the 2? 1/5, right? 1 over 5. Times, we don't need a raised dot, but you can write 1. What is the x to what power? 2/5. Again, if you're not figuring out what's going on, you got to raise your hand. The x is to the 2/5. Class, what is the y to? 3/5. Right? And again, as you start doing a bunch, you start getting used to it. Now, number 6 is that other form. Number 6, though, is the exact same thing. I don't have time to do the color. It's a 7 index and 5 to the 4th power. It's just another way of stating the exact same thing. Doesn't look like it, but it is. So this is going to be 5 to what power? 4/7. 5 to the 4/7 power. And that's what's going on in these. All right, what about going the opposite direction? Now you got to do it the other way. Okay. Thank you, Windows. Let's start with a radical sign. What's going to be the radicand? Say it if you know it. 7. And to the 1st power, but we're not going to bother to put the 1, right? And what's the index? And do we write 2's for indexes? We don't write them, but it is a 2. And that's the answer, right? Square root of 7. 7 to the 1.5 power, square root of 7. So you look at number 2. Start with a radical sign. What's the radicand going to be? 11 what? 11 cubed. What's the index? 5. Now, by the way, when it's a number, you should convert it. So you should simplify this into the 5th root of, and you should punch this in your calculator, 11 times 11 times 11. It's a funny number. It's 13,313. 13,313. I think that's right. Trust me on it. All right, look at number 3. Here's the key to number 3. I'm going to try not to go too fast here. Notice they both have the same denominator. And the denominator is the index. So my 4 is going to be my index. Inside I have what? 3 to the first. We'll just write as 3 times n x cubed, right? 4th root of 3x cubed. Does that make sense? We took this and made it a single radical. Now notice number 4. Are the denominators the same? If we're going to write this as a single radical, and that's what we want, a single radical, we need a common denominator. So get a common denominator. Because remember, that common denominator makes the same index. All right, little fraction action. I'm going to use black. What would our common denominator be? It would be a 12, right? It would be a 6, I agree. So let's multiply the 3 2/3 by a 2 on the bottom to get a 6. Whatever you do at the bottom, do the same thing on the top. The z times a 3 on the bottom to get a 6. Whatever you do at the bottom, do the same thing at the top. And y to the 5/6. Okay, just for clarity's sake, let's rewrite. We have 2 to the 4/6, z to the 3/6, y to the 5/6. Is everybody okay with that? So what is our index? 6. So now we have a 6th root. Our first number is going to be 2 to what power? Z cubed, y to the 5th. And do we leave it 2 to the 4th? Now, numbers you got to multiply out. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's the 6th root of 16. All right, don't have time for the last 2 examples, but that's okay. I will quit there. Homework tonight, foundational lesson. Get good at converting between forms, and that will be great. You are dismissed.